All right, in this video, we are going to look at factoring quadratic trinomials. And what that means is basically we're going to get this thing back into this form. But before we start that, I'm going to start by multiplying this out. And we're going to do that by expanding using the distributive property. So if you recall from the previous video, when we expanded using the distributive property, we broke this parentheses apart. You could really break either one of them apart, but we had x out here, and then we had x plus 6 here, and then we multiply by a positive 1, and we multiplied that positive 1 by x plus 6 as well. And so what we did is we took our x times x, and we had x squared, and then we had x times 6, so we had 6x, and then we took 1 times x, so we had another 1x, and then we took 1 times positive 6, and that gave us a positive 6. We saw that these two things were like terms, and so then we combine those to say x squared plus 7x plus 6. And really what I want you to notice here is what happens when we actually start factoring this. So we can see here's the result. Okay, we got here from multiplying these, so now we should be able, when we factor this, we're going to get back to this step over here. So let us begin. So the first thing I'm going to do is I'm going to look to see which which factors of 6 add up to 7. So factors of 6 means what things multiply to get 6. So a positive 6, as a matter of fact. So I'd have 2 times 3, negative 2 times negative 3, 1 times 6, and negative 1 times negative 6. All of those are our different factors to multiply together to get 6. And I'm going to look to see which one of these add together to get 7. And you could probably quickly see it, but here we get, if we add these two things together, we get 5. If we add those two things together, we get negative 5. If we add those two things together, we get 7. And those we get negative 7. So clearly, this is going to be our 1 right here. So we want to consider 1 and 6. Okay, so what that means is we're going to take this 7x and we're going to split it into positive 1 and 6. So I'm going to say now x squared plus 1x plus 6x plus 6. So all I did again was I split this 7 into 1x and 6x. And then I'm going to look to see what is common between these two values and what is common between these two values. So what's common between these two is I've got a value of x. And when I say what's common, like what's a common factor between these two things? So what can be factored out, what can be divided evenly or equally into both of these terms? So we can see that x is one of them, and what we're left with is x plus 1. So if I factor x out, so I think to myself, x times what gives me x squared? X times x gives me x squared. X times what gives me 1x? X times 1 gives me 1x. And then I'm going to add, and because we've got the addition here, and I'm going to look to see what is common between these two things. And we could say, I could factor out a 6 from those two things. So if I bring a 6 out, then what I'm left with is, what I'm left with is 6 times what gives me 6x? That's going to be x. 6 times what is going to give me positive 6? That's going to be plus 1. Now here's your first check. If these two things are exactly the same, then you know you've done it right. These blue needs to be the same, or let's not say blue. Let's say these parentheses need to be the same. If they're not the same, need to be the same. If they're not the same, then something isn't right. You haven't factored properly. And then since we've got this, we're basically right here. Look at this. The only difference is I've changed the colors. I've accidentally changed the colors on these. So we've got x plus 6 instead of x plus 1, but we've got our two pieces here, and we're left with x plus 6 times x plus 1. So there we go. We've just now factored this. And I want you to notice that when we factor this, or when we expand this, when we go over here, if we look to see what made this 7x, it was the 6 and it was the 1. So when we multiplied x times 6 and we multiplied 1 times x, that gave us this. And similarly, when we factored this out, we're looking, this x times this 1 was our 1x. This 6 times the x gave us this 6x. So we basically we're looking at how do we break. We're basically looking at the exact opposite. If you look at this, look at this. This is step 1, but this is step 4 down here. Here's step 2. That's step 3 down here. Here's step 3. That's step 2 up here. And here's step 4. That's step 1 right here. So when you look at it, we've got a direct connection to each of these things. So that's how you factor a quadratic trinomial. Now, what if you were looking at something that had a number in front of here? This is called factoring when you have when a does not equal 1. We say a does not equal 1 because often when we think of a standard form quadratic, we think of it in the terms of ax squared plus bx plus c. And what that means is we've got something times x squared plus something times x plus some constant. So here, we're not going to do a whole lot different than what we did up above. Let's actually move this. We'll move this over here. We're not actually going to do a whole lot different. But the thing that is, what we are going to do is we're going to look at what 3 times negative 10. We're going to look at the factors of 3 times negative 10 and what factors of those add up to negative 13. So 3 times negative 10 is negative 30. All right, so I've got to look for the factors of negative 30 that add up to 3. Sorry, that add up to negative 13. So I'm going to look at negative 1 and positive 30, 1 and negative 30, negative 2 and 15, 2 and negative 15. Oh, wait a minute. 2 plus negative 15. If I added these two things together, I would get a negative 13. So as I'm working my way down, I found my pair as I started just kind of doing my mental math there. Because I could have gone to 3 and 10 and so on. But I don't need to go any further. So what I'm going to do is, again, I'm going to split this middle term into two pieces. I'm going to have 3x squared, and then one of my terms is going to be 2x, so positive 2x, and then the other term is going to be minus 15, minus 15x, minus 10. So this is simply negative 13 rewritten strategically using these values. So now we're going to look to see what is common between these two, what is common between these two. So here, the only thing that's common, a common factor between these is x. So I'm going to factor out an x, and I'm going to be left with x times what gives me 3x squared? 3x. X times what gives me positive 2x? That's going to be plus 2. Okay. And then what is common between these two terms? Well, I see I've got a negative here, so I'm going to pull out a negative. And these things are both divisible by 5. So I'm going to, I think, 5 seems to be the highest factor in there. So minus 5. So then I've got my parentheses. Negative 5 times what is going to give me negative 15x? That's going to be 3x. Negative 5 times 3 is negative 15, so negative 15x. Negative 5 times what gives me negative 10? That's going to be a positive 2. Oh, hey, check here. Are these two things the same? Yes, they are. Good. So I'm on the right track. So now one of my parentheses is going to be x minus 5, and the other set of parentheses is going to be 3x plus 2. Now, let me just say, as you get more comfortable with this, maybe you don't like this idea of this minus 5 or factoring out a negative. You're not always going to be able to avoid that, but I could do this same exact thing if I bring this down. If I bring this down, I could actually swap these two things around and I would still get the same exact answer. So let's take our 2x and let's take our negative 15. Oops, that's a positive 2x. Going to just do some quick rearranging here. So we're going to do that and we're going to do that. All right, so now let's look again. This is a new problem, or it's the same problem but slightly different. Let's look to see what is common between these two things. What is common between these? Here now I actually have a 3 and an x can be factored out of this. So I take a 3x out, and what I'm left with inside here is 3x times x would give me x squared. 3x times what gives me negative 15? That's going to be minus 5. And then over here, I'm going to have plus, plus some number, and it looks like I've got a common factor of 2. So I have plus 2. So what's left on the inside? 2 times what gives me x? 2 times what gives me negative 10? Look at that. My red numbers are the same, so I'm doing the right thing. So I have 3x plus 2, and I have x minus 5. Both of these two things obviously are the same thing. So if you've got a number in front of here, you look to see what is common. What do you multiply together? 3 and negative 10. 3 times negative 10. And that 3 times negative 10 equals negative 30. It's actually the same as when you factor without a number right here. If that were gone, where we look at like, oh, what is the factor of negative 10? It's actually the same thing. We're just taking 1, where we'd have a 1 here. 1 times negative 10, like you did in the previous video, or the previous part of this video. But so there you go. That's how you factor with a common, or not with a common, with a value that does not equal 1.